So P7, solving inequalities algebraically and graphically. Okay, and this is going to include absolute value inequalities as well. So solving absolute value inequalities. Yes. Yes. The absolute value of u is less than a, then u is in the interval negative a to a. So the absolute value of u is less than a if and only if negative a is less than u is less than a. And 2, if the absolute value of u is greater than a, then u is in the interval negative infinity to negative a, or a to infinity. So the absolute value of u is greater than a if and only if u is less than negative a or u is greater than a. All right. So example from 1 through 8, it says to solve the inequality algebraically, write the solution in interval notation and draw its number line graph. Down goes the Sharpie. All right. Let's see. Number 2 to start with. The absolute value of 2x minus 1 is greater than 3.6. Anybody remember what we have to do when we're solving absolute value inequalities? Okay, yep, we have to change the sign when we do that. Alright, so then solving for x over here, get what? And over here? Okay, is that how I leave my answer? How would I leave my answer? Okay, so x is less than negative 1.3 or it's greater than 2.3. Okay. Y'all were trying to give me and as if it was one that is in between. Okay, but this is not the notation it wants it written in. It wants it in interval notation. Okay, so I would rewrite this as negative infinity to negative 1.3 union, okay, you can draw it with a U, 2.3 to infinity. Okay, if these were greater than or equal to, less than or equal to, then it would be a bracket at the 2.3 and the negative 1.3. But since it's just less than or just greater than, it's parentheses. And then last thing is it wants us to graph this on the number line. This is an interval. This isn't x and y points. Oh. So then now when I graph this, okay, it's greater than 2.3, so it goes this direction with a parentheses. Okay, and then negative 1.3, it's less than that, so we color it in over here. Okay, and you're welcome to use 2 colors or something. I would just ask that you not use like pink or red, preferably when you do it. Though I have been grading in like teal and purple and stuff like that, so preferably at least not pink or red. But other than that, you can use whatever, and I'll make do with it. Do these kind of ring a bell? I know this step here of writing an interval notation is probably different, but it kind of rings a bell, at least the solving part, the graphing part. Okay. All right. Let's look at another one. Paper is polka dotted. It's for dot week. That's great. All right. So setting this one up, what do I have? Just a refresher with inequalities, what happens if I divide by a negative or multiply by a negative? Yep. We flip it. Alright, somebody solve for x over here. Over here. Alright, so with this one, what does it look like? I would use brackets this time. Why is this an and? Yes. So, just so you can see it, I mean, this might be the easiest way for you guys to be like used to it since this is how we've done it for so long, but make sure you do write in an interval notation. Okay, it is greater than or equal to negative 19, but it's also less than or equal to 29. Okay, so this would tell us it's an and, okay, as was pointed out. So then when I draw up my answer in interval notation. It gets brackets on both sides like that, and that would be my interval notation answer. Okay, and I am very strict about if I tell you interval notation, it needs to be written in interval notation. If I say inequality notation, it needs to be written in inequality notation. Okay. Yeah, so this is the inequality notation. This is interval notation. No. Pretty much all of these are asking you to do them in interval notation. If it doesn't specify, it's interval notation, always. Yeah, we did it right here. That's how ORs are always written. Alright, so graphing this, what does my graph look like then? That would be an OR. Yes, okay, there are brackets at both facing inward. Okay, if it's an and, it's all going to the middle. Okay, if it's or, they're both going out. Okay. So with the or problem, okay, notice we had two separate intervals here, okay, connected by a union. That's what this U stands for. Okay, and then our graphs face outward. Okay, but then with our and, we just have one of them, so they face inward in that direction, okay, together, based on this. The easiest way is to look at it in inequality notation when you're first writing it, probably, especially since that's what you are more familiar with at this point. But eventually you'll get to the point where you don't even need to see this and you'll just know that it's going here. Like when I am done solving my problem, because we were doing something kind of like this the other day in one of my other classes, I literally look at it and I say, okay, x is greater than negative 19, and I know it's or equal to. Say, but x is also less than 29. And so then I think, okay, on my number line, what would that look like? So I kind of think of it as my number line, and then I write my interval. But just think about like where it is. And then also you can plug in points. If I plugged in negative 20, is negative 20 greater than negative 19? No, it's not. So that's not in my interval. Okay, now negative 20 would be in this one, but it's not in this one. So you have to have numbers that work for both. So like 0, 0 is greater than negative 19. 0 is also less than 29. So I know that it's in this interval here. Okay? Alright. The next one just say to solve the inequality. So our answer is going to be written in interval notation. Okay, like I said, that's all of them are going to be written that way. Actually, I probably still have enough room to do it here. I need to focus it. So essentially doing the same thing, just not with absolute value now. Yeah, if it has like bold lines to like look at, it focuses better. For some reason with like the fat Sharpies, it like goes out of focus a lot easier. I'm not really sure why, but anyways. All right, number 10. (6x squared minus 13x plus 6 is greater than or equal to 0. So this one is not absolute value, so I don't have to do it twice or anything like that. I'm not doing two separate problems. So, what, or how would I go about solving this? Why? Possibly. I'm not sure. What could I factor it into? What? It's possible. I'm not sure if we need that or not, necessarily. That would work. It doesn't really matter which one I do where, so I'm just going to do, in this case. Alright, so then, grouping stuff, what do I get? Or what do I pull out from these first two? Leave me with? And now I can regroup. 3x minus 2 times 2x minus 3 greater than or equal to 0. No, absolutely not. So now what do I have? Okay, so I have x is greater than 2/3, x is also greater than 3/2. Well, I'm just checking something because of the answer that they have over here. I'm trying to make sure it makes sense. X is greater than... That's what I was trying to check and making sure we didn't need to flip something because... So what are y'all telling me the answer should be in interval notation? Does anybody agree with him? The question is, does a number in here work? Does like the number 1 work? Six minus 13 is -7 plus 6 is -1. Is -1 greater than or equal to 0? So that should be your answer. Yeah, find a number between that, because it looks like it should all be going that direction. But pick a number that you do know between there. That's something easy, preferably. Because if I were to plug in, let's say 0, yeah, 1 is in between. That's why I plugged in 1. But if I plugged in 0, then I would get 6 is greater than or equal to 0, which is true. Okay. Makes sense, kind of. We're going to do another one, don't worry. Um, 14. 21 plus 4x minus x squared is greater than 0. If y'all would prefer, I could also rewrite it for you. Yes, and that makes sense because of the negative signs here. It makes more sense to do it that way. Though it could technically go either way. It would work, but. So then what do I pull out from these first two? Over here. So then now what? Sorry, too far. So what do I get in this left one? Over here. So what is this? It's an and, okay, because x is greater than -3, but it's also less than 7. So what would my interval look like? -3 to 7. Okay, because it's got to be in there. Okay, if I picked a number like, let's say I picked -4, that would be -16 minus 16 plus 21. Does that work? Did I just do that wrong? Oh, it would be -16 minus 16. It should be -32 plus 21, which is not greater than 0. So I know that stuff on the left side doesn't work. I could try, I'm going to do 10 just because I think 10 would be easier. -100 plus 40 is -60 plus 21, not greater than 0. So those don't work. So this is my interval, -3 to 7. Okay. Do we want to do another one? Yes. x cubed minus x squared minus 30x is less than or equal to 0. What can I do with this one? Okay, yep, factor it into what? Which one's positive and which one's negative with 6 and 5? And then what does that go into, or what does that break up into? Now what? Hmm? And I get, obviously that one stays. What about this one? And then in interval notation, I have what? I'd recommend trying a couple numbers here somewhere before you make your interval. And try like 1. 1 minus 1, 0, minus 30, less than 0. Okay, that's true. How about negative 1? Negative 1, minus 1, negative 2, minus, or plus 30. It's greater than 0, so negative 1 doesn't work. I'm just trying random numbers to see if we can figure out. So we said 1 works, negative 1 does not work. Based on that, ideas on what our interval could be. You could also try like 7 and see what happens there if you want. 343 minus 49. Huh? What number worked? 7 works. 343 minus 49 minus 210, or 221. No, 210. Pretty sure that's greater than 0. Okay, so for this one, okay, something less than negative 5 does work. So we're looking at negative infinity to 5, or sorry, negative 5. Union. We know that the stuff between 0 and negative 5 doesn't work because we checked negative 1, but stuff between 0 and 6 does work. So, and also this should be a bracket, and then 0 to 6. Okay, so this is a lot of checking stuff and verifying. Okay, so you do have to be able to plug numbers in and check and see what makes it true. So once you write your interval, go back and check a number and say, does this make sense? and ensure that it does. Okay, because there's a lot of factors that have to play in here to ensure that it works. Okay, because you have so many different possible answers. That's why you have to go through and check it. Because you have a function that's being cubed, so anyways. Alright, I'm going to go ahead and give you guys a couple to start trying. There's probably going to be a little bit more we do with this stuff. But some of these are like solve the inequality graphically, and I'm not sure what I want to do with that yet. So, anyways. Questions about any of these problems before we do that, though? Alright, and we can go over this more after the quiz, obviously, on Friday. Okay, my goal, like on the quiz, or not on the quiz, this isn't on the quiz, on the test is not to trick you with these. Okay, I'm going to try to give you ones that are pretty obvious what they are. Stuff more like 1 through 8 is more reasonable than the ones like 9 through 16. Not to say you can't have one like that, but you're more likely to see one like 1 through 8. Okay. So 1, 5, 7, and 9, and that'll be it for this part right now at least. Okay, since it is Wednesday, you can hold off on all of this until we get the rest of it on Friday. Okay, so after the quiz on Friday, so like don't stress out about getting it all done by, you know, Friday. But I also do want you working on this stuff now, okay, not other stuff, or it might become homework.